Today we're going to talk about powers of I. If we look at complex numbers are the form a plus bi, and that's how we want to write complex numbers. We don't have any exponents in that form, so if we have exponents with a power I, we're going to talk about simplifying those today. I to the first is equal to I squared is equal to -1. I to the third, we can rewrite I to the third as I squared times I to the first, because property exponent says that 2 times 1, if we multiply, we add the exponents, and 2 plus 1 is 3. I squared is -1, using what we already know, and I to the first is I. -1 times I is negative I. I to the fourth, we can use what we already know. 2 plus 2 is 4. So I to the fourth is I squared times I squared. I squared is -1. And I squared is also -1. -1 times -1 is +1. I to the fifth, I to the fourth times I to the first, because 4 plus 1 is 5. I to the fourth we just found to be +1. I to the first is just I. And 1 times I is I. Direct your attention that I to the fifth was equal to I to the first was also equal to I to the sixth is I to the fifth times I to the first. I to the fifth, 5 plus 1 is 6. I to the fifth we said was I to the first is I. And I times I would be equal to I squared. And we know that I squared equals -1. Direct your attention again. I to the sixth equals -1. I squared equals -1. Perhaps a pattern is showing up. I to the seventh would be I to the sixth times I to the first. I to the sixth is -1. I to the first is I. And -1 times I is just -I. Again, we see that pattern confirmed here. I to the third was -I. And I to the seventh was also -I. I to the eighth would be I to the fourth times I to the fourth, because 4 plus 4 is 8. And I to the fourth was equal to 1. And I to the fourth is also equal to 1. And 1 times 1 is 1. So we see again, I to the fourth was 1. I to the eighth was also 1. If we continue in like fashion, you would notice that I to the ninth would also equal I to the 10th would equal -1. I to the 11th would equal -I. And I to the 12th would equal +1. And so on. The powers of I, and therefore repeat every fourth power. We can use the I clock to help us figure that out. So I to the 22nd, if we want to figure out what that simplifies to, we can use the I clock. We can simply start counting, and we can count to 22 to figure out where we are located in the pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We're located at this point of the pattern, which would be the same as I to the 10th, I to the 6th, and I to the 2nd. So I to the 22nd would be equal to -1. However, what if we didn't want to count? If we didn't want to count, we could take 22 and we could divide 22 by 4, because it repeats every fourth power. And by doing so, this would help me figure out where we are in the pattern. 4 goes into 2 0 times. 4 goes into 22 5 times. 5 times 4 is 20. 22 minus 20 is 2. 4 goes into 2 no times. We get a remainder of 2. Well, if we look at our I clock, the remainders are the numbers on the inside of the clock. So we get a remainder of 2, so that's where we are in the pattern. So I to the 22nd would be equal to -1. What about I to the 57th? We could count. That's a logical, legit way to find the answer. We could start at 1, 1, 2, 3, 4, 5, and count all the way to 57. Or we can divide by 4. 57 divided by 4. 4 goes into 5 one time. 1 times 4 is 4. We subtract, we get 17. 4 goes into 17, or we get 1, we bring the 7 down. 4 goes into 17 4 times. 4 times 4 is 16. We subtract. 17 minus 16 is 1, so we get a remainder of 1. So we go back to our I clock. We get a remainder of 1. So that tells me that that's where we're located in the pattern. So I to the 57th is equal to I. I to the 68th. Again, we could count 1, 2, 3, 4, all the way to 68, or we can divide by 4. 4 goes into 6 one time. 1 times 4 is 4. We subtract, we get 2. We bring the next number down. 4 goes into 28 7 times. 7 times 4 is 28. We subtract, we get a remainder of 0. That's why 0 is on the clock and not 4. We get a remainder of 0, so that tells me that's where we are in the pattern. So I to the 68th would be equal to the number on the outside of the clock, which is positive 1. So I to the 68th would be in the same row as I to the 4th, I to the 8th, and I to the 12th. I to the 79th. We can divide by 4 again. Again, we could count if we wanted to. 4 goes into 7 one time. 1 times 4 is 4. 7 minus 4 is 3. 4 times 3, 4 doesn't go into 3, so we bring the 9 down. 4 goes into 39 9 times. 9 times 4 is 36. And we subtract, we get a remainder of 3. So we go over to our I clock. The remainders again are on the inside. Remainder of 3 tells me we're at the negative I part of the pattern. So we get negative I as our solution, or our simplified version of I to the 79th. If you have any questions, you can contact Mr. Washington through Mind or through his email. Thanks.